So we are recording right here, and what I want to do is review section 9.3, and not only that, review also section 9.1. And what's the difference between the two sections? We're talking about the difference of standard form and vertex form. So we need to know everything about standard form. Y equals ax squared plus bx plus c. These are just numbers. And if I asked you to graph a standard form equation, you would have to use the formula x equals negative b over 2 times a, and that'll give you the vertex x value, and then you plug it in to find the y value. That's the stuff that we've been doing for the past couple of weeks. It does take a while to graph a standard form quadratic trinomial equation, right? The vertex form is way faster. Why is that? Because you could see the vertex just by looking at the h and the k. And in order to identify h, remember, you have to think opposite of what you see when you're identifying h. The k value, you take it for what it is, right? Now, let's also go back and compare that the a value, it doesn't matter whether it's standard form or the a value of a vertex form, it's the same thing. It tells you, it gives you the same information. You first begin with, if the a value is positive, then it opens up. If the a value is negative, then it opens down. And that's technically the first transformation when we're talking about from original parent graph to the final graph. The first transformation is if your a value is negative, then you would say that it reflects over the x-axis, which really means that it opens down, okay? In addition to that, the a value, if it's more than 1, it causes a vertical stretch. If it's an a value that's a fraction between 0 and 1, in other words, it's less than 1, it's going to be a compression. So a stretch causes the parabola to get narrower, and a compression causes the parabola to get wider. Let me explain that one more time. So if you have y equals x squared, your a value is 1. If you change that a value to a 2, it's gonna stretch. It stretches my arms up. It makes it vertically stretched, right? If I have the a value of 1 and I change the a value of 1 to 1/2, like y equals 1/2 x squared, it gets compressed, it gets crushed, it gets wider, okay? So again, the a value, if it's greater than 1, it's a stretch. If it's less than 1, it's a compression, it gets wider, okay? And that makes total sense because when you multiply any number by 2, which is bigger than 1, it's going to cause it to grow, right? It's going to stretch it. If you multiply any number by a fraction that's less than 1, like 1/2, it's going to cause it to shrink, to compress, right? So we're going to be talking about vertical stretches and compressions. If the a value is bigger than 1, it's a stretch. If the a value is less than 1, it's a compression. On parabolas, when it's an a value bigger than 1, it's a stretch, which causes it to be narrower. If it's a fraction that's less than 1, it's a compression, which causes the parabola to get wider. And of course, the h and k are your vertex values. You know what? Let me pause right here, and let me just go to an actual parabola, okay? So let's say that we have this parabola right here, and we're trying to find out, like let's say on the quiz tomorrow, let's say I give you this parabola, and then I give you several different functions. Like maybe we have the function, let's say option A is y equals 2 parentheses x plus 2 squared plus 4. Let's say option B is y equals negative 2 parentheses x plus 2 squared, and so on and so on. The question is, will we be able to identify which vertex form parabola is represented right here? Well, in order to graph, or in order to write a vertex form parabola, you need the a value, you need the h value, and you need the k value. Now, obviously, the vertex is your h and your k. Now, what is this vertex h and k value? That's the coordinate negative 2, positive 4. So you technically know that your h value is negative 2. You technically know that your k value is positive 4. So what we're missing is the a value. Okay, the a value is what's missing. We know h is -2. We know k is +4. Now, it is kind of tricky when you plug it in. It has to look opposite of what you see here, right? So, but before we even get to h and k, let's look at the a value. This does open down, so that must mean that it's negative, right? So if I were to write my equation, it would be y equals, it's a negative a value, but the question is it -1? Is it -2? Is it -3? Remember, the a value of 1 would imply the pattern 1, 1, 2, 4, 3, 9. And if we take a look at the vertex and we go 1 over, 1 down, that is so far 1, 1, go back to the vertex, 2 over, 1, 2, 3, 4 down, that is technically the pattern 1, 1, 2, 4, 3, 9. If you go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, it will be that parabola. So the a value really is -1. And then you have x minus h, x minus the h value of -2. That's technically going to be minus a -2, which ends up being +2 squared, which makes total sense because you have to end up with the opposite of what you see there, right? That's +2. That means that your h is actually -2. And then plus k at the very end. Your plus k will be the +4. That's your k value. So ladies and gentlemen, we looked at the parabola and we came up with the equation. Isn't that amazing? Pretty cool, right? And we need to be able to do this on tomorrow's quiz. I give you a parabola. You should be able to identify the a value. Is it positive? Is it negative? Is it a regular U-shaped curve, or is it narrower, right? Or is it wider? And then what is your hk value? And that's what belongs in here and right there. Now, let's say the multiple choice options were not in vertex form. If they were in standard form, right? If they were in standard form, well, you would still look at the a value that's in front on standard form. You would still look at the a value, and if the parabola opens down, then you know that this has to be a negative, right? But of course, you need the rest of the equation. And how would you find that rest of the equation? You would go to the multiple choice options and you would find the vertex using the vertex formula and see which one of those actually gives you the vertex -2, +4. Okay? Anyway, let's try a couple more here. So we have this parabola, and let's write this one in vertex form. Vertex form is y equals a parentheses x minus h. That's an ugly minus sign, I apologize. Minus h squared plus k. Okay, so is the a value positive or negative? We know that it's positive because it's opening up. Is it wide, is it narrow, or does it stay the same? It looks like it stays the same. It has the regular pattern 1, 1, 2, 4, 3, 9, right? So if you count 1, 1, yep, 1, 2, 1, 2, 3, 4, yep, it has the pattern 1, 1, 2, 4, 3, 9. So that tells us that the a value is 1, okay? So when you're looking at your multiple choice options, look for the one that has a 1 or not even a number at all. It's an invisible one. But it cannot be a number that has a negative sign because it doesn't open down, it opens up. It can't be a number like 2 or 3 because if there were an a value of 2, it wouldn't be the pattern 1, 1, 2, 4, 3, 9. It would be the pattern 1 and then 2 and then 2, 8 and then 3, 9 and then 3, 18 by modifying that pattern. I know it's a lot of information. I hope we understand what I'm talking about here. Anyway, this a value is 1. Where's the vertex? The vertex is the hk value, which in this case is 2, 0. So what is my equation going to be? It's going to be y equals parenthesis x minus 2 squared plus k plus 0. You don't even need to write the plus 0. There's your answer. Y equals parentheses x minus 2, open parentheses, or close parentheses to the second power. Okay? I hope we get that. Let's try another. This guy right here, the a value for sure is negative because it's reflected over the x-axis. In other words, it's opening down, okay? What else? The hk value is 0, 0, so you're not going to have anything there, you're not going to have anything there. So this is obviously, let's say our multiple choice options could be like y equals negative x squared, right? Or it could be like option B, y equals negative 2x squared, or maybe option C, y equals negative 3x squared. All of these have different a values, which ultimately, now let's do an option D here, y equals positive 2x squared. I don't know. So we have multiple choices here. It is opening down, which means it's negative. It could be A, could be B, could be C. If it is A and the A value is 1, then you should be able to go 1 over 1 down. But notice that it's not there, right? It's a little bit, it's not at 1 over 1 down. And if you go back and you go 2 over 4 down, 1, 2, 3, 4 down, you can see that it's off. It's not right. So it cannot be negative 1, okay? In other words, the pattern for when your A value is 1, 1, 1, 2, 4, 3, 9, it did not work, right? So that means that option A is not a possibility. When you look at option B, it has that new A value of negative 2, the new A value of negative 2. You could multiply by negative 2, multiply by negative 2, multiply the outputs by negative 2, and it will give you the new pattern 1, negative 2, 2, negative 8, and 3, negative 18 if you're multiplying all those outputs by negative 2. So here's your new pattern, 1, negative 2, 2, negative 8, 3, negative 18. And if you do go 1 over and 2 down, you really will end up on that coordinate, which is on the parabola. If you go to 2 over and 8 down, 1, 2 over, 1, 2, 3, 4, 5, 6, 7, 8, you really will end up right there on that parabola, right? So that is one method of identifying which one's the correct one. In addition to that, so this is the correct answer right here, option B. In addition to that, you could, remember, a graph is really an infinite amount of answers to an equation. So you could pick any coordinate you want. Like you could pick that coordinate right there, which is the coordinate 1 comma negative 2. And if you were to plug in the 1 for the x, 1 for the x on the one where we think is the answer, and negative 2 for the y, see if it gives you a true statement, because it should work. The 1 for the x, 1 squared is 1, 1 times negative 2 is negative 2, and negative 2 really does equal the y value of negative 2. So you could plug in coordinates as well to verify which one's the correct answer. Anyways, I hope we understand what I'm talking about here. Let's move on to the final part of the quiz tomorrow. In addition to being able to find the vertex of equations that are in standard form, in addition to being able to understand the graphs, whether they're in standard form or vertex form, we also need to describe transformations of the original parent graph to our new graphs, okay? From the original parent graph to our new graphs. So let's jump to, we had this homework assignment and we should be able to graph. That's what we were talking about. This homework assignment was particularly vertex form, but we should also be comfortable with standard form. And for the last part of the homework on this section 9.3, we had these notes up here, and it tells us exactly how to describe transformations from the original parent graph to whatever graph you have now. So what does the original parent graph look like? You go to a regular XY table, the original equation y equals x squared, that's the easiest parabola. That's the parabola that we call the parent graph. That has the coordinate 0, 0, has a coordinate 1, 1, has a coordinate 2, 4, has a coordinate 3, 9, right? So this is a regular U-shaped curve. It's not too wide. Whoops, that's ugly. You know what I'm saying. It's not too wide. It does have the pattern 1, 1, 2, 4, 3, 9, and you map it over to the other side. That's your parabola. That's what a parent graph looks like. And what we want to describe on transformations is how the original parent graph changes to whatever other graph they give you, okay? So if I take a look at, let me group this. If I take a look at this one down here, okay, there is, what kind of changes does it go through from the original parent graph to this one? You're going to first think of vertex form, y equals a parenthesis x minus h squared plus k. And you begin, as you read it from left to right, you begin with the a value. If you see a negative sign, that would mean that it gets reflected over the x-axis. That's why on the notes right here, I tell you, first question to ask yourself is, does it get reflected over the x-axis? If the a value is negative, then it does get reflected. Obviously, our a value right here is 1. It does not get reflected over the x-axis, right? So you don't have to worry about mentioning that. When you move on to the second question, does it get vertically stretched or compressed? Well, that depends on the actual a value, right? The a value, in this case, there is no number, which means that it's the number 1, which means that it doesn't get vertically stretched. It doesn't get compressed either. It stays exactly like the parent graph. So you don't have to mention a vertical stretch or a compression because it doesn't have any. Last but not least, look at your HK shifts. Your H is -2 and your K is +0, so the K is 0. Now, this is technically your vertex, -2, 0. Now, if you look at your original parent graph, which had the vertex at 0, 0, and now at this final graph, which has the vertex at -2, 0, what kind of changes does it actually go through? You would say it shifts to the left. It's simply thinking opposite of what you see right here. Now, of course, if you would have had a +7 on the outside, you would say it shifts 2 to the left and up 7. If you had a -3 on the outside, it shifts 2 to the left and down 3. If you had a k value, but you don't have a k value, so you don't have to mention anything. So the only transformations that happen from the original parent graph to this new graph h of x is it shifts 2 to the left, okay? Let's take a look at a couple other ones here. This guy right here, it does not get, you know what, let me go to a hard one here and see if you guys understand what I'm talking about, all right? The first question to ask yourself is, does it get reflected over the x-axis? As we read the equation, the very first thing that pops out is a minus sign. That means that it opens down. That means that the first transformation is it gets reflected over the x-axis, okay? That's the first transformation. So that's the first thing you saw, that's the first thing you mentioned. Now, let's look at the actual numeric value. We already dealt with the minus sign. Now let's look at the actual numeric value of 2, all right? What does that cause the parabola to do? Does it get wider? Does it get narrower? But the correct words that I should be asking is, does it get vertically stretched, which means narrower, or does it get vertically compressed, which means wider? It gets vertically stretched. Thank you guys for participating, and thank you Angel and Kimberly for getting it right. It gets vertically stretched. Remember, the a value, if it's a number bigger than 1, and I know you're thinking, wait, it's -2. No, we already dealt with the negative sign. The negative sign means that it gets reflected over the x-axis, that it opens down. So the actual number 2, if you multiply any number by 2, it's going to get bigger, right? So think about that. On your regular parabola, if you multiply by 2, it's going to get stretched, right? So it gets vertically stretched. Now, if it would have been a fraction that's less than 1, whenever you multiply any number by a fraction less than 1, it's going to get smaller, it's going to get compressed. So if it's bigger than 1, it's a stretch, a vertical stretch that is. If it's less than 1, it's a vertical compression, okay? So right here, because the a value is 2, we already dealt with the negative sign, because we have the number 2, it gets vertically stretched. And we would say by 2, okay? Now, somebody just asked the question, so if it's a fraction, is it a compression? Yes, but the fraction has to be a value less than 1, right? I mean, think about that. If you multiply 20 by 1/2, which is less than 1, 20 becomes 10, it's a compression, okay? But if I multiply 20 by 3/2, that's really a 1.5. That'll become 30, right? It grows. So we got to understand that it has to be a fraction that's less than 1. If it's a fraction and it's bigger than 1, then it's still going to be a stretch. Okay. But anyway, we already dealt with, from left to right, we dealt with the reflection over the x-axis. We already wrote that down. We said a vertical stretch by 2. We already wrote that down. And now, last but not least, what does this mean and what does that mean? Well, we know that this is our h value, and we have to think opposite of what we see. And this is our k value, and we take that for what it is. So the final portion of the transformations, of the description of how it transforms from the original to this one, the final is the shift. It finally shifts 4 to the left and 8 units up. And ladies and gentlemen, we have described every single transformation from the original parent graph y equals x squared to this new complicated looking graph y equals -2 parentheses x plus 4 close parentheses squared plus 8. Now I could actually, let me actually do this. I'm going to show you the different changes that happen. Check it out. Here's your original parent graph. The original parent graph is y equals x squared, which is a regular U-shaped curve. Wow, that's ugly. Sorry. I'm trying to draw it good, but it's not that good. It's not too wide. It's not too narrow. It's a regular U-shaped curve. It has a pattern 1, 1, 2, 4, 3, 9. It's opening up. This is the equation y equals x squared. Now, let me show you how this original one changes to this guy. It begins with the negative sign, which means it gets reflected over the x-axis. So that identical parabola will be reflected over the x-axis like that. Man, that's just ugly. Sorry about that. So anyways, that is the first transformation. The negative sign means it gets reflected over the x-axis. And then it gets vertically stretched by 2. If I take this parabola and stretch it vertically, it's going to get narrower, right? So it gets vertically stretched by 2. That 2 right there is going to cause my parabola to get stretched, to get narrower. Okay, now this is not precise, but it's a good sketch that we're doing so far. Now, so far we have not messed with the vertex. The final transformation that says it shifts 4 to the left, think opposite of +4, so that's 4 to the left, and 8 up. I need to take this narrower green graph, and actually shift it 4 to the left, 1, 2, 3, 4, and 8 up. 1, 2, 3, 4, 5, 6, 7, 8. So it will shift and have a new vertex up here, and it'll be definitely narrower than the original red graph that was opening up. So we've described the transformations. We've actually done all the transformations. We will be able to read this equation on tomorrow's quiz, and if I give you 4 multiple choice options of parabolas, you should know that it's this green one right here because it has the vertex -4, +8, and because it's slightly narrower and opening down. Okay, so let's practice. How about you guys right now go through and tell me the 3 transformations that happen from the original parent graph y equals x squared to this new graph t of x. I'm going to pause it, and you guys are going to tell me step 1. What do I write? Of course, the first transformation that happens as you read it from left to right is this negative sign. What does that mean? And we have the correct answer, Charles. Thank you, Angel, also, and thank you, Santiago. It gets reflected over the x-axis. That's what the negative sign means, that it gets reflected over the x-axis. What does that mean in English? That it opens down instead of up, right? Okay, now we move on to the next transformation. That's analyzing the actual value that you see right there as the a. Now, you already dealt with the negative. Let's deal with that fraction. And Angel, you got it right. Because it's a fraction less than 1, it's going to be a compression. So we write down it gets vertically compressed. Or you could have said vertical compression of 1/2. Or we're going to say vertically compressed by 1/2. Okay? And for the third and final description of the transformations, you got to look at your h and k. Think opposite on this guy. Take this guy for what it is. So what is our third and final transformation? Kimberly says it shifts 3 units to the left and 4 units up. You are absolutely right, Kimberly. It shifts 3 to the left, because obviously if it's a plus 3, it's going to be a minus 3, which means 3 to the left, and 4 units up, because you take that one for what it is. And that's describing every single transformation from the original parent graph y equals x squared to this new graph t of x that has all these different changes. Now, of course, the other ones are even ridiculously easier. Right here, quickly, it gets reflected over the x-axis, and then it gets shifted 2 to the left and 3 down. Those are the only 2 transformations that it goes through. Let's look at this one over here. I apologize for not writing it down. The video is really long, that's why. It doesn't get reflected, so I don't even mention any reflection, but I do have a vertical stretch of 2, and then it gets shifted 4 to the right and 6 down. So the more you practice, the easier it'll get. And not only that, knowing these transformations will really help you out when it comes to identifying which parabola is which on your quiz tomorrow.